basically the topic that we're going to do today and tomorrow is like hydrogen. The only thing is this is something that you started up with right from the beginning of chemistry, and whatever topic you touch upon in an organic mainly is dealing with hydrogen. So kind of it is a revision of something and some bit of what you're going to touch upon in each and every topic. So whatever you do today is very elementary, basic, and very important for all bases of the rest of the chemistry. So it is like something that you must have done either in redox or in say atomic structure, or you will be doing in solid state or in S and P block chemistry. So some reactions which are very simple, but they are very important from both your examination point of view and chemistry point of view. So it is important, so just keep making down the notes as we actually go ahead. And the best part of it is like when you do something very simple, the best thing to do is like when you're doing something simple, try and memorize it then and there itself. See, it is important to keep it in your memories because you have to appear for the examinations. Otherwise, I would have just asked you to just go through. So just try and memorize in today's and tomorrow's class because the topic is extremely simple. Simultaneously a little theoretical also because you will have a number of reactions of hydrogen. And when we talk about hydrogen, you know it's the first element of your periodic table. And the positioning, because when we did the periodic table, the positioning of hydrogen is really uncertain because till date it is like a little bit of a controversy. Why? Because it has resemblance because of its electronic configuration. What is the electronic configuration? And the property that it possesses because of this 1s1 make it similar to your alkali metals also, because it can give an electron and simultaneously it can take up an electron. So the very first thing that we should discuss is nothing but let's discuss the resemblance with the alkali metals first. All right, resemblance with alkali metals. And before that, as the name suggests, you know that hydro is like, you know, why is it given the name hydrogen? The etymology of the word is like hydro means it's basically related to water, and gen means it's like giving birth. So it's like it gives birth to waters because it is like an element which is a constituent of water. So here when we talk about alkali metals, see it has only one electron in its outermost shell. So it can easily give away the electron. And what do you say that the property, they possess a very low ionization energy. Why? Because it is easy to remove the electron. Once it gives the electron, then it simply becomes 1s0, which satisfies that condition, you know, to have the complete outermost shell configuration. Here in this case it becomes 0 because the maximum your S can accommodate is 2 electrons. So this all of us all are familiar with. The other thing is like it has a very high ionization energy, very low ionization energy. And why do I say that? Because it is easy to remove the electron. But when you compare it with alkali metals, it is different. Then another thing that we can talk about is it forms stable oxides. All this and more is like already done. It forms stable oxides. Oxides in the sense when you talk about say sodium, what is the oxide that it forms with oxygen? It is Na plus OS2 minus. Very basic chemistry that you've done. You know it forms your Na2O. Similarly your H also forms your H2O. So it forms stable oxides. Then it also forms stable halides. Halides also of the form of, if this has NaCl, this also easily forms your HCl, right? Then if you talk about sulfides, same case. So it can form stable oxides, halides, sulfides. Many of the compounds which it forms are similar to those of the alkali metals. So when I'm saying that we are talking about hydrogen, right? Now hydrogen has many properties which are similar to alkali metals. And why do we say that they have properties similar to alkali metals? It is because of the outermost electronic shell configuration, which is 1s1. So they also have the tendency to lose an electron and then form compounds in their ionic state, and so does your hydrogen has. So here we say that hydrogen actually can form stable oxides, halides and sulfides just in a similar fashion as your alkali metals can, right? Then if I talk about the differences from the alkali metals, then the difference, one of the major difference is the value in the ionization energy. Say if the ionization energy of alkali metals, get a roundabout idea, is around 512 kilojoules, the ionization energy for your hydrogen atom is around 1312 kilojoules, right? So there's hell lot of a difference. So here you have that the ionization energy of hydrogen is much more, and that is because of its size, and it is right there, your electron is right there in the very first shell, so it is held tightly by the nucleus. So this much of chemistry and giving reasons you've done. So here we have it's like I'm talking about per mole, of course. I'm talking about the ionization energy. If I talk about for the alkali metals, it is around about 500, and for this it is around 1300 kilojoules per mole. So it is high. Another difference that we can talk about is that H plus does not exist as freely as your Na plus, Li plus and other alkali metal atoms. That is because again of its size. Another thing is like sometimes when you talk about X-ray crystallography, this is like when you talk about all, there are X-ray diffraction patterns. I'm just telling you, this is one technique. X-ray diffraction technique is one technique to elucidate the structures of some unknown compounds. ठीक है, कुछ structures हैं जिनका compound का structure, कुछ compounds ऐसे हैं जिनका structure is not known. So for that we use a technique called X-ray diffraction pattern. So hydrogen cannot be easily detected in those also, whereas your alkali metal atoms can be detected. Why? Because it does not interact with matter. All these patterns, did I talk about spectro to you last year in your last class? Spectroscopy, what is it? I must have. When we talk about quantum levels, you know what are quantum energy levels? Just reminding you of that. Hydrogen also has. Let me tell you, this was the first element for which your spectra was elucidated. And when we talk about branches of chemistry, just a recap because you're coming back after a break. Quantum mechanics was the study of microscopic properties or particles. Classical mechanics was the study of macroscopic particles. And then I did state that from classical mechanics, what is the difference? Here you have the energy levels for any system at different energy levels. So it has a discrete energy. It is like if you make your electron jump from this level to this level, it needs to have certain packet of energy, and that packet of energy needs to be defined. It is just as good as I took an example that if you're jumping from that side and I dig a deep pit here and you jump from the other side, if you have lesser energy then also you fall in the pit, and then there is another pit on the other side of this level. So if you have to have that much amount of energy to safely reach to the other side. Got the point? So quantum talks about different energy, discrete energy levels. Whereas in this case of classical mechanics, you have all the energy levels so close to one another that one can easily pass through it. So it is like a continuous form. This difference you have to remember. It is like a continuous form that we talk about here, and quantum mechanics talks about discrete energy levels. This is clear? Now, when quantum mechanics say हम solve करते हैं, the only problem that can be solved for a real atom in quantum mechanics is that of your hydrogen atom. It can solve only hydrogen atom problem, that is the problems which contain only one electron, and similar systems. What can be the similar systems? You can have He plus, you can have Li2 plus, and so on, because all of these will contain only one electron. So those who contain one electron can be solved completely using your quantum mechanics. And what is that equation called which can solve it? Schrodinger wave equation. This can solve. Now when I was talking about spectro, I was talking that now from quantum mechanics you get different levels. Levels ki information is taken from quantum mechanics. Then when you have a microscopic particle sitting in its ground state and it has to jump to the excited state, you have to give some energy to it. थोड़ा सा energy चाहिए ना, even if you have to go to the upper floor and just walk through, you need to have some energy within yourself. So some energy, that energy is generally given in the form of, just understand this concept, it's a very simple concept. Now in order to make your electron jump from one level to another level, you need to supply radiation or energy to it. So that radiation can be in the form of any of the many electromagnetic radiations. In electromagnetic spectrum I gave you a number of radiations, rays, cosmic rays, gamma rays, X-ray, UV, visible, IR, microwave. So there you can have a number of radiations. So depending upon that radiation, whatever is required, we'll give it, and it will jump from a lower level to a higher level. When it jumps to a lower level from a lower level to a high level, what it does, it absorbs energy, and that absorption of energy can be plotted as, say, energy versus intensity. Means that, say, a weird value, say if it takes 10 units of the energy, so then you will get a peak at 10 units, whatever values. बात समझ में आई? This is how the spectra is recorded. फिर उस spectra की information से हम structure निकालते हैं. Got the point? Get it from the top? Quantum से we get different energy levels. ठीक है? और जब हम इलेक्ट्रॉन को नीचे से ऊपर जंप कराते हैं तो वो कैसे जंप होता है? We make the microscopic particle interact with, और वो भी कौन सी? Electromagnetic radiation. We make our microscopic entity. So when matter interacts with electromagnetic radiation, you say that that branch is known as, क्योंकि matter है, matter के अंदर electron है. When matter interacts with radiation, electromagnetic radiation, you have the jumping of electron from a lower level to a higher level, and that interaction, if it yields some kind of a spectra, that leads to your spectroscopy. जब ये नीचे से ऊपर जाता है, it will correspond to absorption. जब ऊपर से नीचे आता है, it will correspond to emission. This is clear? Now one of those techniques that I am talking about is your X-ray, and I was telling in that X-ray hydrogen cannot be detected, means it cannot interact with that particular electromagnetic radiation because of its small size. So we started from here and entered into another pool. So coming back to now, similarities is like done. It can easily lose an electron. So because of that, it can form similar types of stable oxides, halides, sulfides, etc. And then it has properties similar to alkali metals. Generally, it is placed above them, right? Hydrogen is placed on the top left corner, where it is the site for the alkali metals. But the ionization energies are not that comparable, right? Another thing with which you can have similarities of your hydrogen atom are like resemblance with, you can talk about what? Halogens. And you can answer. Why with halogens? Because halogens need just one electron more to complete their octet. Here hydrogen also needs just one electron to complete its outermost shell, right? So here they have resemblance with halogens as well, and there you talk about when an electron gets added. Now reminding you of what basic definitions you've done. What is your ionization energies? We've compared the values of ionization energies. The ionization energies for alkali metals was around 512 kilojoules per mole. For hydrogen it was around 1312 kilojoules per mole. What was your ionization energy? It was the energy required to remove an electron from the outermost shell. But remember, it is the energy required. Okay? And what was your electron affinity? It was the energy released when an electron is added. And you had different names for that. You had electron affinity, you had electron gain enthalpy, and or electron gain enthalpy or electron affinity. So you can have different names for that. So now here we are talking about that both of them are willing to accept an electron. And the moment your hydrogen accepts an electron, here it will act as an H plus the moment it gives an electron. If it has to behave like halogens, it will have to form an H minus. And whenever you have compounds which contain H minus, you call them hydrides. Let's talk about them. The outermost configuration of halogens is what? It is Ns2Np5, fluorine, chlorine, bromine, iodine. It is Ns2Np5. In case of hydrogen, it is 1s1. Both need just one electron to complete the outermost shell configuration. And then the ionization energies are comparable with that of halogens. What is the ionization energy of halogens? That is 16 something, that is 1680 to give you the exact value, 1680 kilojoules per mole. So it is said to be comparable. The difference is not as drastic as in this case. So the ionization energies of halogens is comparable. Just as your halogens form homonuclear diatomic molecules. Homonuclear diatomic molecules means, homo means same, nuclear, homonuclear means same nucleus, diatomic means 2. So it forms F2, Cl2, Br2, etc. What does your hydrogen do? It is stable in the form of H2. So this is again a resemblance to your halogens and not alkali metals, which do not occur like that. Hydrogen forms hydrides with carbon just like halogens. I am just giving you an example. Hydrogen forms compounds of carbon just as your halogens. So if they form CH4, you have CCl4. In both the cases, your carbon is tetrahedral in nature, sp3 hybridized in both the cases, right? And how is it different from the halogens? They are less reactive. Hydrogen is less reactive in comparison to your halogens. So one difference is that. Another difference is that the electron affinity of hydrogen is less than the electron affinity of halogens. Okay? Yeah. What is the difference in electron affinity and electronegativity? Whatever you want me to revise, because it's like a revision kind of thing for you. Electron affinity is the energy released when an electron is added. Electronegativity is the tendency to gain an electron. So that's a tendency, right? And when it is actually done, whatever energy is released, you call it electron affinity. That's the difference. So electronegativity, positivity, ionization energies, electron affinity, all are related. But just understand the main difference between ionization energy and electron affinity. One is the energy required to remove an electron, and the other is the energy released when an electron is added. Okay? So the electron affinity of hydrogen is less. So mainly your hydrogen has a problem. The controversial position of hydrogen is because of these two factors only, that it has resemblance both to alkali metals as well as halogens, but simultaneously it has differences also with both of them, and we've discussed some of them right now. Another thing is, like when you talk about say alkali metals generally occur like, they can occur in the atomic form. You can have sodium, you can have other alkali metals also, but when you talk about hydrogen atom as such, it is very difficult to obtain. In fact, once you get dihydrogen, this is hydrogen or dihydrogen molecule, so once you get this, if you want to get hydrogen atoms from dihydrogen, it needs a temperature of about 5000 Kelvin. It needs a temperature of about 5000 Kelvin. And let me tell you, at 2000 Kelvin it has been tried by scientists. When it is heated to 2000 Kelvin, at that time only 0.08% of there are chances of hydrogen atom getting formed. But at 5000 Kelvin, you have chances of about 99.95%, approximately 99% and more. You have full chances of getting hydrogen atoms. But even after forming hydrogen atoms, what is the lifetime? It is 0.3 seconds. So 0.3 seconds means that if it will live only for 0.3 seconds, and then it will again form H2 or get involved with any other anion which is there, if it is available. So it is like that kind of a mystery, and this is like one of the most basic ones from where you start studying and understanding chemistry. because it's just one electron. Yes. See, basically at 5000 Pe you will get hydrogen atoms, and if you go beyond that, definitely you will get hydrogen atoms. The lifetime may depend upon that. They will also be formed for about the same. See, when you are increasing the temperatures, what you want is hydrogen atom. The moment you reach 5000 Kelvin, you get hydrogen atoms at that. And if you take the temperature directly at 6000 Kelvin and make your hydrogen, dihydrogen fall into that category, then it will give you hydrogen atoms for sure. And the lifetime of hydrogen atom as it is like very less. So it will be around about the same time. Okay, if only I had done it myself. So here we talk about the differences. So let's start talking about the molecules which are formed because of hydrogen. One of the most basic, or before talking about the molecules, another very important thing that when you talk about hydrogens is like isotopes of hydrogen. What are isotopes? Which have the same atomic number but different mass number. And here in this case you all know what are the three ones which have, you have protium, deuterium and tritium. What you have is you have these three, right? And then you get many questions in your examination, at least many in the sense every year there is a question which is very simple in scoring. You have which of the three isotopes has no neutron. You know that this is a proton, your mass number minus the number of electrons or the atomic number is going to give you the number of neutrons. That is like very simple basic chemistry of 8th standard. So which of them has no neutron? That's this. Then there are more questions to it. Let me just tell you that the chemical properties of all of them is just the same. The chemical properties of the isotopes are the same. Why will the chemical properties be the same? Because the number of electrons are the same in all these cases. And then there is a difference in the physical properties because of their change in the mass number. Alright. And chemical properties generally they are same, but only there is a difference in thermal conductivity. There is a difference in thermal conductivity. So this may be noted down as an exception. You have similar chemical properties, but when you talk about thermal conductivity, that is like thermal conductivity is different. Alright, so when we talk about thermal conductivity, and that is due to difference in their enthalpy of bond dissociation, that we will talk about. Then when we talk about, see, protium, protium is also known as ordinary hydrogen, because out of the three you know that this is the ordinary hydrogen. So that's easy to make out because this question has also been asked, which is the ordinary hydrogen. Ordinary hydrogen is your simple 1H1. Then for deuterium it is known as the heavy hydrogen, right? And it was this deuterium because of which a Nobel Prize was given in 1934, because a scientist could find out that there is another hydrogen atom which exists. Alright, then you have, it is the heavy, and then you know the number of electrons and protons, I do not have to talk about that. And the only isotope of hydrogen which is radioactive is your tritium. So ordinary hydrogen, heavy hydrogen and radioactive hydrogen. So these are the names which are associated with it, and when you talk about the number of protons or neutrons, you can easily tell which has how many. Yes? It is just given the name. It is not the heaviest one. If you talk about the mass number, which has the most? Yeah, so 3. The names which have been assigned as they were discovered from time to time. Like in 1934, Urey got a Nobel Prize for it. I just stated 1934, a scientist called Urey, he got the Nobel Prize for finding out another atom or isotope of hydrogen which has a greater mass number. And because it had a greater mass number at that time in comparison to your hydrogen atom, it was named heavy hydrogen. So you call it a misnomer. The name is like a little misleading. So here you have ordinary hydrogen, then heavy, and then the only radioactive one. So the question is generally asked like which of the following is radioactive. So you will maybe having other atoms also to confuse you, but if at all you were given a tritium there, then that is the radioactive option. Then which isotope have high thermal conductivity? When we talk about thermal conductivity, see, if you talk about thermal conductivity, that will also depend upon your thermal expansion of the element that you are talking about. All of them all have one electron. So ideally speaking, you would expect that thermal conductivity is also the same. But it has been found that when thermal means what? When you supply heat, and conductivity means the speed at which your electron is moving. So in that case, you expect here the electron is bound together along with neutrons, so it has more interactions with other subatomic entities. It's quite difficult to understand at this stage, but how thermal conductivity is different is what I am telling you. Each of them has one electron. So one electron means that the thermal heat conduction of the electron should be the same in all the cases. Sabke paas one electron hai. But what happens here is like you have one electron and no neutron. So this electron is relatively freer, right? Then here you have one electron and you have one proton. So here one electron, one proton is there in all, because the number of electrons is equal to the number of protons. Please, so just take care. So one electron, it has along with that one neutron. So another subatomic entity is there with which the interactions will be more. And then here you have two. So which of the three you expect to have the highest thermal conductivity? In this case, the one which is like the freer one. Alright, then the meaning of radioactive element is that when you talk about a radioactive element, it is like there are certain elements which when kept just like that have the property of emitting radiation spontaneously on its own, and they keep deteriorating over a period of time. So there is one radioactive chemistry also that probably you will do as a part of your IIT course. So what happens to these elements is like they have a half-life. Their half-life is generally given by a formula which is known as 0.693 upon the rate constant. Now again, rate constant is something that you will understand in chemical kinetics now. So all these radioactive elements are associated with a half-life that decides onto their rate of disintegration. Disintegration means that, like for example, cobalt-60 is radioactive. Your radium, the lower bottom of your periodic table, generally you see that there are radioactive elements, like you do lithium, sodium, potassium, rubidium, cesium, francium. We say francium is radioactive. So all these radioactive elements have been placed at the bottom of each of your groups, and here when you talk about them, you say that each of them is associated with a half-life, okay, and they have the property of disintegrating themselves, and they emit radiations which are very, very, very harmful also. We've seen the effect of cobalt-60 that happened recently in Delhi only, because of which one person had died also. It's like quite interesting as to what happened. I'll just quickly tell you. It was like a huge radioactive chemical equipment was dismantled, and when it was dismantled, it was given to a normal scrap dealer. You understand scrap dealer? Generally, as you have the raddiwala, so you have a scrap dealer. That scrap dealer dismantled that equipment, and he found something which is very shiny. So he thought probably it may be something which is very expensive. So because he felt it was expensive, the person who actually dismantled and found it, what he did, he took a part of it, or probably whatever he could get from the dismantled, kept it in his wallet, closed it and kept it. So what happened? Whatever radiations were emitted out affected his health, affected his body, and because of that, he was just not keeping on well. So, but why were the effects lessened and not dominant in the entire city? The effect was less because the half-life period had already got over. So towards the end, the element's radioactivity keeps on reducing with time. So the radioactive, so they do last because time is infinite. So half-life, 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 half-life till it reduces to almost negligible. So it keeps on having the radioactivity keeps on getting reduced. Keeps on decreasing. That depends upon this. That depends upon the half-life. No, so yes, then it needs to be replenished, and there are ways of actually doing that. What is this? This is a rate constant. Rate is like the speed at which your reaction is occurring. Now we are deviating. We are not jumping into your 12th standard immediately. So this is rate constant, and what you understand by rate is the rate at which the reaction is proceeding. So if you want your rate to be high, you have to see, depends on what you want at the instant go. You have to make sure that your half-life is less. And if you want your half-life to be more, you have to make sure that it slowly, steadily disintegrates. So they're inversely proportional, and you can just find out a relationship using that. Okay, coming back. There are many elements which are available. So depending upon what kind of a radioactivity use you want to make use of, then you can have, right? Because there are specific chambers which are like safe to store your radioactive elements. So just remember that all that glitters is absolutely not gold. So just take care of that. Okay, so if I ask you which isotope of hydrogen has no neutron and give you options, you would have actually told me. Which of them is radioactive has already been shared. Now let's talk about some of the molecules of hydrogen atom which actually are of importance to us. One of them is the very basic one, that is H2. Now there are two types. Dihydrogen is the most abundant element in the universe. H2, all of you all know what is H2. It is the most abundant element in the universe. Be careful in reading your question. Universe. Whereas the abundance on earth is very little. The abundance on earth for hydrogen is very little, but it is the most abundant element in the universe. You know that about 70% of the universe is made up of hydrogen, dihydrogen, but universe. And the Earth's atmosphere has only 0.15%. Only 0.15% is present in the Earth's atmosphere. But otherwise it is the most abundant molecule in the universe. Okay, then it is the principal element then, of course, if it is most abundant, so then it becomes the principal element of the universe. Let's talk about the two types of hydrogens which are possible. See, hydrogen means you have just one electron, and that electron, you know now the significance of spin also. That can either be an upspin or it can be a downspin. How do you understand spin? It's not like the electron is always vertically up or vertically down. It means it can either be clockwise or it can be anti-clockwise, right? If I am talking about H2 molecule, so then in that case, if say both my hydrogen atoms, because H2 molecule is made up of two hydrogen atoms, if both the hydrogens have the same spin, if they have the same spin, then you call it ortho hydrogen. If both the hydrogens have, this is also an important question from your examination point of view, if they have the same spin, then you call them ortho hydrogen. If they have the opposite spin, then it is called the para hydrogen. And both these are also known as allotropes. What are these called? These are known as allotropes, where there is a difference in only the spin. Out of ortho and para, let me tell you, ordinary dihydrogen has 75%. If you talk about an ordinary hydrogen molecule, then 75% of it exists in the ortho form, and you have only about 25% of it existing in the para form. Para should be more stable, but then there is an effect to understand here. Now, I was expecting that question to come up. Now, say you have a molecule which has, here the spin multiplicity will be what? What will be the total spin? It will be half plus half, that will be 1. So the total spin multiplicity here in this case will be equal to 2s plus 1 is your spin multiplicity. I hope you've done the meaning of spin multiplicity, I don't know. 2s plus 1 is your spin multiplicity. So here your spin multiplicity will be equal to a triplet. So generally it exists in more in the triplet form. And what about this case? Here the spin will be equal to half plus half, which is equal to 0. So it is more half, and you knew it well. So half minus half is equal to 0. So here what will be the spin multiplicity? It will be 2s plus 1. So that means 2 into 0 plus 1 is equal to 1. So this state is known as a singlet state, and this is known as a triplet state. Here you have both with an upspin. So which of the two molecules do you expect, which of the two allotropes do you expect to be more in the sense interactive when it comes? If I am saying that both the molecules are stable, because H2 is stable, H2 is stable. Why? Because it is completing its outermost configuration. It needs just one more electron, it takes up another electron from the other hydrogen atom. So out of both the cases here, you talk about the triplet state of the ortho here, which will be more interactive, right, and simultaneously more stable also. And in case of para, where you have the opposite spins, what we basically talk about is that in case of para, you have the spin multiplicity to be equal to less, and because you have both the upspins which are readily here, once it does the pairing, so it will be stable within itself and will become quite inert. If it gets paired up, it will become quite inert and will not be willing to interact. Whereas in this case, if you have both with the same spin and interact, so there will be more chances of interacting. Here again, the thermal conductivity of para hydrogen is about 50%. Thermal conductivity of para hydrogen is about 50% greater than, it is 50% greater than that of the ortho. The thermal conductivity of para hydrogen is 50% greater and the melting point is less. So just note these points. Melting point is about 0.15 K less. So you have the melting point of ortho more and the melting point. These are just the experimental observations that we have. How come dihydrogen comprises 90% of the sun's atmosphere? Considering its temperature, H2 must dissociate into hydrogen. A very, very, very good question. Now, a question says that you have, I am telling you that dihydrogen is one of the most abundant element in the universe. And then you are saying that 90% of the Earth's sun's atmosphere also comprises of H2, where the temperature of sun is drastically higher. Now here, remember that the lifetime, first of all, of hydrogen atom is very low, right? Another thing that is very important to be understood here is that this is the question from Anil Kumar, okay? So now this H2 becomes H plus H, right? Every reaction, now you've done thermodynamics also, that's really good for me, is associated with enthalpy of the reaction, okay? This enthalpy of the reaction is positive, of the order of 500s, I don't remember, so I don't want to make a guess. It is highly endothermic. So is this reaction feasible? Favorable? Agar endothermic means it needs to absorb a lot of energy, right? Now what happens there? It readily, because the temperature is very high, so it readily will have the hydrogen atoms, but because you have your 1H1 again forming your H2, if this is positive reaction, when you reverse the reaction, what happens to delta H? It becomes negative, highly exothermic, so you are having nuclear fusion reaction again and again. Fusion means two छोटे atoms are combining to form a bigger molecule. So here you have the fusion reaction and again, which is exothermic and hence increasing the temperature further. Getting the point? When two hydrogen atoms combine with one another, what it yields is a big molecule. So this molecule, hydrogen molecule, is formed releasing a lot of energy. If it releases a lot of energy, what will it do to that particular surface? It will increase its temperature, so the temperature is enhanced even further. And then that is why nuclear fusion, and you will be doing fission also, both these reactions release a lot of energy. Fission is just the opposite of fusion. So here, not exactly opposite, you have different examples to cater to the problems. Here when you talk about H and H reacting, it's kind of a nuclear fusion reaction, which is much more favorable from inorganic chemistry point of view also, and you can relate it to your delta G factors also. Here you have H2 giving H and H, which is an endothermic reaction, and from inorganic point of view we say that because it is endothermic, we say that the reaction may not be as much feasible as the opposite direction is. So, and we know that the lifetime as it is for hydrogen atom is negligibly small. If it is negligibly small, what will it do? It will immediately form H2 again and again and again and increase the temperature further on to make it 90%. Correct? So then let's talk about the lab preparation. Okay, so now let's talk about the lab preparation of hydrogen molecule. Yes? The thermal conductivity of parahydrogen is about 50% times greater than that of ortho. Then let's talk about the chemical reactions now. See the lab preparation first. Considering its temperature, H2 must dissociate. The question is done. So here is what we have, the lab preparation first for. What are we doing now? H2. Now the lab preparation of H2 is you can use any metal atom, generally the zinc, which is used to react with H plus. This all you must have prepared for your board school examinations. So what you have is you get Zn 2 plus and you get H2. Can you just tell me what's happening to H plus? Is it getting oxidized, reduced, what? It is going from +1 to सोच रहे हो? So it is getting reduced and Zn is getting, so H plus is acting as a oxidizing agent. Okay, so here you have this forming Zn2 plus H2. I'll come to it. And there is another. So generally it can be any dilute acid, because H plus cannot be just H plus. I cannot give you an ion, yellow ion, and just form H2. So it has to come from some acid, and that acid is generally your HCl. So generally H2 comes up with sometimes a pop-up sound, as you've done in 10th standard. Pop-up is like as the bottle opens, yeah. So here what we have is Zn plus H. Another way of forming is like zinc, and remember that never ever is a pure zinc used. So because pure zinc cannot actually give you dihydrogen to that, it is very slow. Whenever you have a pure metallic form of zinc, it is a very slow reactant. So we do not want slow processes. Today it's like a fast world, you need fast reactions. Slower are also important. So so here you have the Zn interacting with NaOH. So how do we take this Zn? What we do to enhance the reaction is we add some impurities in order to enhance the reaction in this case. So here you get sodium zincate, Na2 ZnO2 plus H2. Now the question that has come here, ma'am, parahydrogen have electrons with different spin. Then how can we relate this with molecular orbital theory? There's a question saying that parahydrogens have different theme. Now see, this is only for the person who asked the question. Otherwise the rest of you will lose track. Parahydrogens have different spins. Means you have one electron here and another electron. Let this be electron number 1, this be electron number 2. Now molecular orbital theory you've asked me to relate it to molecular orbital theory. Molecular orbital theory में क्या होता है? You have each electron associated with both the nuclei. I don't know if I taught that. Molecular orbital theory talks about each electron to be associated with both the nuclei. So here you just have to talk about labeling of the electrons so that you relate it to each one. So your psi, the wave function, because I told you each and every microscopic entity is known by a wave function. ये सब चीज़ें तो मैंने बताई हैं, so you can understand each and every electron is associated with a wave function. Any subatomic particle, any microscopic entity is always talked about with the help of a wave function, just as each one of you is known by your names. So you have each of the microscopic entities known by a wave function. So if I have to talk about the wave function of the first electron, okay, तो इसकी spin जैसे भी है clockwise या anti clockwise, in molecular orbital theory it becomes psi A of 1 plus psi B of 1. Why? Because this first electron is now associated both with A as well as with B. समझ आता है तो ठीक है, otherwise ये कोई question पूछेगा नहीं, just to satisfy your to quench your thirst of this question. So what you have for the second electron? You have psi A of 2 plus, you tell me? So B of 2, and your net spin, your next wave function will be psi of 1 into psi of 2. अब इस केस में हमारे 2 इलेक्ट्रॉन्स ले लिए, पर कभी भी हमारा टोटल वेव फंक्शन ये नहीं होता. टोटल वेव फंक्शन क्या होता है? टोटल वेव फंक्शन होता है ये वाला वेव फंक्शन इनटू द स्पिन वेव फंक्शन. ठीक है, तो वो वाला स्पिन वेव फंक्शन जो है ना, मान लो इसको हम कह रहे हैं दिस इज सिमेट्रिक. ठीक है, तो हम जो वेव फंक्शन लेंगे ना उसको, द स्पिन वेव फंक्शन इन दिस केस देन विल हैव टू बी एंटी सिमेट्रिक. यही क्वेश्चन था, टू रिलेट द पैरा हाइड्रोजन विथ the spin of the para hydrogens with MOT. MOT is a concept that you will do after 12th standard in detail from chemistry, intricate chemistry point of view. अभी के लिए सिर्फ इतना समझो, पैरा हाइड्रोजन में ऑपोजिट स्पिन होती है. ठीक है, ऑपोजिट स्पिन का मतलब है that one has an up spin and the other has a डाउन स्पिन. तो उसका हम एक मैथमेटिकल एक्सप्रेशन लिखते हैं. तो उसको अगर हमारा ऑर्बिटल फंक्शन सिमेट्रिक है तो हमारे स्पिन्स को क्या होना पड़ेगा? एंटी सिमेट्रिक. और अगर हमारा ऑर्बिटल वेव फंक्शन एंटी सिमेट्रिक है तो स्पिन को क्या होना पड़ेगा? सिमेट्रिक. सो दिस इज हाउ यू जनरली रिलेट टू मॉलिक्यूलर ऑर्बिटल थ्योरी. और वैलेंस बॉन्ड थ्योरी भी बता ही देती हूँ, इफ यू कैन गेट इट एट दिस पॉइंट वेरी वेल, बिकॉज अभी कोई प्रेशर नहीं है, नो एग्जाम्स नो टेस्ट अभी फॉर द टाइमिंग. वैलेंस बॉन्ड थ्योरी में क्या होता है कि अगर हाइड्रोजन के पास अपना इलेक्ट्रॉन है और दूसरा हाइड्रोजन के पास अपना इलेक्ट्रॉन है, so each of the electron will just be associated with its own nucleus. मान लो ये है A atom, ये है B atom, ये इलेक्ट्रॉन नंबर 1, ये इलेक्ट्रॉन नंबर 2. तो इसके अंदर वेव फंक्शन हम कैसे असाइन करते हैं? psi of A is associated with just 1. तो इलेक्ट्रॉन नंबर 1 का कुछ लेना देना नहीं होगा B atom से, it will just be associated with अपना वाला atom that is A. So psi A of 1, this is how we write. फिर सेकेंड इलेक्ट्रॉन को भी तो लेना है, क्योंकि टोटल वेव फंक्शन तो फर्स्ट इलेक्ट्रॉन का इंटू सेकेंड इलेक्ट्रॉन का होगा. तो सेकेंड इलेक्ट्रॉन का वेव फंक्शन हाउ विल बी टेक इट? दैट विल बी psi B of just 2, because 2 will just be associated with B. So ये VBT भी हो गया, MOT भी हो गया. I hope whatever question you were asking I answered it. I don't know whether I did. Because if you have to relate the spins to the molecular orbital theory, you have to actually drown yourself in a big pool. We say that orbital wave function is symmetric. जैसे अगर मतलब मान लो ये मेरा 1s है, ठीक है, कभी भी ये हाइड्रोजन का 1s है. अब बिफोर आई डू द प्रिपरेशंस यही समझ लो एक बार. दिस आई थिंक वी डिड दिस इन योर MOT जब हमने किया था. अगर हमारे पास ये एक हाइड्रोजन एटम है तो s ऑर्बिटल है, एक इलेक्ट्रॉन है, दूसरा एक s ऑर्बिटल है. ये मैंने बताया था जब भी s और s आपस में इंटरैक्ट करेंगे, एक बार वो पॉजिटिवली इंटरैक्ट करेंगे, एक बार वो नेगेटिवली इंटरैक्ट करेंगे. सो व्हाट यू हैव इज, सो व्हेन यू हैव अ पॉजिटिव इंटरैक्टिंग विद अ पॉजिटिव, द नेट रिजल्ट विल बी टोटली अ पॉजिटिव. सो दिस विल बी अ सिमेट्रिक वेव फंक्शन. ठीक है, ये एटॉमिक वेव फंक्शन था, ये मॉलिक्यूलर वेव फंक्शन हो गया. क्योंकि हाउ इज अ मॉलिक्यूलर ऑर्बिटल फॉर्म्ड? बाय combination of two atomic orbitals. So this is an atomic orbital, this is an atomic orbital, and this combines to form a molecular orbital. Yes, क्योंकि s is like as it is, you have s along the internuclear axis. जो भी internuclear axis के along होता है उसको हम sigma बोलते हैं. तो 1s plus 1s will give you a sigma orbital because it's along the internuclear axis. And because when same signs interact, you call it a bonding molecular orbital. So in this case, what is getting formed is a bonding molecular orbital. तो ये symmetric हो गया. अब ये क्या है? प्लस माइनस ऑफ प्लस. प्लस माइनस ऑफ प्लस का मतलब है ये प्लस को क्या हो जाएगा, ये अब हो जाएगा माइनस. ठीक है, सो नाउ यू हैव योर प्लस ऑफ s इंटरैक्टिंग विथ माइनस ऑफ s. सो दिस इज बिकम एंटी सिमेट्रिकल, एसिमेट्रिकल. ठीक है, एंड जब भी ऑपोजिट साइंस आपस में इंटरैक्ट करते हैं तो वी गेट anti-bonding molecular orbital. So here for hydrogen also, irrespective of the spins that the electrons possess, s plus and s will form this. Generally क्या होता है, सबका generally hydrogen का एक ही spin होता है. So if you consider it to be moving in clockwise direction, so generally सबका will be moving in a clockwise direction. So एक का clockwise दूसरे का clockwise will combine to form your कौन सा हाइड्रोजन, ऑर्थोमोर. ठीक है, अब एक का स्पिन इसकी वजह से चेंज होगा तब जाके we will get para. So which of the two is more in your H2? Ortho. कितना? Around 75% and 25%. एक बार प्लस से इंटरैक्ट कर रहा है, दूसरी बार भी प्लस से इंटरैक्ट कर रहा है, बट इट्स एन एंटी रिलेशनशिप नाउ. नाउ psi of 1 हमने क्या लिखा, psi a of 1 plus psi b of 1. Let me just share your question with everyone so that the others don't fall out of sync. As it is like a revision kind of a class. What she asked is, she asked कि अगर हमने यहाँ पे प्लस कॉम्बिनेशन और माइनस कॉम्बिनेशन कंसिडर किया, तो जब मैं MOT की बात बता रही थी तब मैंने सिर्फ एक ही कॉम्बिनेशन कंसिडर करा, दैट वाज प्लस. माइनस क्यों नहीं कंसिडर करा? तो एब्सोल्युटली राइट. नॉर्मली प्लस इज लाइक अ बॉन्डिंग वेव फंक्शन. बॉन्डिंग ज़्यादा स्टेबल होता है या एंटी बॉन्डिंग ज़्यादा स्टेबल होता है? बॉन्डिंग ज़्यादा स्टेबल होता है. तो इसीलिए हमने सिर्फ वेव फंक्शन लिखते टाइम वी कंसिडर्ड ओनली दी positive combination. Otherwise you have psi minus of 1 as psi a of 1 minus psi b of 1. So ये भी होता है और ये भी होता है. मैंने सिर्फ समझाने के लिए उस टाइम सिर्फ psi plus लिया. Okay? So this is all. This is according to your MOT only, where one electron is associated with both the nuclei and they will get added up. और वैलेंस बॉन्ड में क्या होता है, each electron is associated only with its own nucleus. Now coming back to the reactions part of it. ठीक है, so the lab preparation is done. Lab preparation is like you make your zinc, which is a little impure, add impurities to react with either any dilute acid or with an alkali or with a base. So then in that case what you will get is, what are we creating? Dihydrogen. Okay, so you get dihydrogen in both the cases. And you can also write down the reaction with concentrated. What happens if zinc reacts with concentrated H2SO4? Dilute H2SO4, you will get your H2 getting liberated. Okay, in many of the books you see an upper arrow. By now you know the meaning of the upper arrow. Means your gas, it is a gas which will just escape into the air अगर उसको रोका नहीं तो. So then you have, agar if you have concentrated H2SO4, then in that case it will form the sulfate plus the SO2 plus water, but with concentrated acid it will not give you H2. So here the gas that is liberated is sulfur dioxide, not your H2. But remember that your zinc reacts with either a dilute acid or with a base to form your H2 dihydrogen. Okay, then the commercial preparation. Now the commercial preparation, the best one is, next we talk about the commercial preparation. In the commercial preparation we talk about the electrolysis of water. And when you talk about the electrolysis of water, you have 2H2O. You know what is electrolysis? You take a chamber in which you have a cathode, you have an anode, and you have a cell, and then you pass electric current into it, and then the chemical reactions which are now occurring due to the current that has been passed on to it, that is known as electrolysis in the presence of an electrolytic medium also, because you need a solution because of which your H plus, because of which your cations and anions can, and this again is a part of your electrochemistry that you will be doing. Remember, electrolytic cell talks about the generation or the chemical reactions which are occurring because of electric current that has been passed. In the galvanic cells or the electrochemical cells, it's the opposite way around. This is what we had done in 11th. In electrolytic cells, your cathode is negative and anode is positive. So cathode gets a name kind of, cations are attracted towards cathode. क्योंकि cations क्या होते हैं? Positive. So they get attracted towards your cathode. Cathode negative, cations cathode, ऐसे याद रखो, cations are positive, ये तो सबको याद है, anions are negative. So cations will move towards cathode, anions will move towards anode. So it's easy for you to tell that where your dihydrogen will be liberated. अब dihydrogen कैसे liberate होगा? H plus दो आएंगे, H2 बनाएंगे and then you will get H2. Where will your H plus go? Cations है तो H2 will be liberated at cathode in the electrolysis of water. So this is all you can actually talk about. So you take your liquid water and do the electrolysis of it to get 2H2 plus O2. You can also do the electrolysis of aqueous barium hydroxide solution. You can also do the electrolysis of aqueous barium hydroxide solution to obtain dihydrogen, but mainly it is the electrolysis of water which is like very general. So that is why normally not asked in the examination. Then another electrolysis which is important is the electrolysis of brine solution. अब brine बोलते ही ना दिमाग में आना चाहिए NaCl. Alright? Electrolysis of brine solution, brine is your NaCl, and it is actually considered to be important because इसके अंदर हम electrolysis of, when we carry out the electrolysis of brine, we are actually producing chlorine. It is used, electrolysis of brine is done for the manufacture of chlorine and NaOH, because both chlorine and NaOH are important for other suitable chemical reactions in very many ways. Industrially they are very important chemicals. So we are talking about Cl2 and NaOH, और इनको बनाते हुए from NaCl we get dihydrogen as a side product. So here you suggest what will be the reactions like. At anode what will happen? Anode पे कौन सा ion जाएगा दोनों में से? ये तो अब anode पे, first of all anode will be what? Anode will be your positive. So you will have Cl minus coming to it. So here your 2Cl minus, remember हमेशा minus signs के साथ, minus और plus cations and ions के साथ you find in brackets written aqueous. Why? Because your ions exist only in aqueous media. This I told you that you cannot have ions existing in gaseous phase. So you have ions existing in aqueous media. So दोनों Cl minus will now combine to give Cl2. Is the reaction complete? Plus 2 electrons. ठीक है, अब यहीं से अपने 12th स्टैंडर्ड के इलेक्ट्रोकेमिस्ट्री चैप्टर के लिए कुछ चीजें याद करो. Anode is positive, cathode is negative. Because it is positive, you will have negative ions. What is happening? Release of electrons. What is release of electrons called? What method? What is happening? This is going from -1 to 0. So what is happening? Oxidation. And oxidation means loss of electrons. So please ये चीजें जो हम कर चुके हैं, and you should be remembering them, that we are talking about oxidation. Oxidation talks about loss or release of electrons, and this will always happen at anode. So remember this. Anode बोलते ही दिमाग में क्या आना चाहिए? That oxidation reaction will occur here. That means loss of electrons will occur here. बाकी तो सब हो जाएगा. At cathode, what will happen is you have the reaction for cathode as you have 2H2O liquid form reacting with 2 electrons to forming your H2 plus 2OH minus, and then you can write down the net reaction. And then whatever Na plus is left in the electrolytic medium, क्योंकि electrolysis हमने electrolytic medium किसको लिया था? NaCl का aqueous solution. So that Na plus will react with your OH minus. You can write Na plus here also. That Na plus 2H2O plus Na plus 2 electrons giving H2 plus 2 NaOH. That will be one and the same thing. In order to satisfy yourself कि Na plus कहाँ गया, वो cathode पे क्यों नहीं आया? तो Na plus भी आया है, मैंने सिर्फ show नहीं कराया. So what you have, the total net reaction can be written as 2Cl minus plus 2 water is giving you H2 plus Cl2 plus 2OH minus plus 2 electrons here in this case. oh sorry, 2 electrons will get cancelled. So the net reaction can be noted down like that. Remember that this is an important method. Electrolysis of water is like something which is very simple, but electrolysis of brine is more important for the production of this. And then let me tell you, this you will do again in your P block chemistry in 12th standard. That is for the production of what? Chlorine. P block में क्या आता है सोच रहे हो? Chlorine. So when you do for the manufacture of Cl2, this is one of the which method? Commercial methods. And what is that? Electrolysis of brine. So the moment you actually start up with your P block and you are doing Cl, तो कुछ चीजें तो पहले से ही आती होंगी. These are like something which you have to actually memorize at times for the preparation methods because it's hard to remember. So you have electrolysis of brine, and that is for the manufacture of Cl2 and NaOH. And what did we talk in context of now? To produce dihydrogen, which is produced as a byproduct. Then the next method is by action of steam on coke. What is your coke? Carbon. So you have steam, say then this would be in the gaseous form, this is the solid form coke, and this at 1270 Kelvin as reproduced from the notes. I am giving you CO gas plus H2 gas. This again is a commercially very important reaction because this reaction gives you CO plus H2, which is known as or syngas. Syngas means synthesis gas or synthesis gas. This is known as synthesis gas, and it has a characteristic that it's very hard to separate out dihydrogen from it. It is not that easy to separate out dihydrogen from it, but dihydrogen is getting produced. So you have the combination of CO plus H2. इसमें से अगर CO निकालना है, that's also very difficult. H2 निकालना है, then also it's very difficult. So this syngas, why it is really important? It is important because it is used for the manufacture of methanol. Now this you will do in organic chemistry chapter, I don't know number, alcohols, phenols and ethers that you will do. So as a part of that you will do that CO plus H2 commercial method given in your NCERT text. So you have C plus H2O giving you CO plus H2. There are other ways of also remembering this. Say you have any of the hydrocarbons, CnH2n plus 2, this is your normal alkane. Pick up any of the hydrocarbons and you react water to it. So say n molecules of water, then in that case you can just remember that this will give you NCO plus 2n plus 1 H2. NCO plus 2n plus 1 H2. Let me just check. Yes, this is gas, this is also gas, this is also gas, and your hydrocarbon may or may not, that also going to be a gas. So here you pick up any of your hydrocarbons, and that will, and you check it out from methane, write it yourself. Methane plus water will give you CO plus 3H2 because one carbon ho gaya na, N is for the number of carbon atoms. So you have CH4 plus water will give you CO plus 3H2. So that is again your water gas because the mixture of CO and H2 in whatever form is, and it is also given that syngas these days is produced from sewage, your newspaper wraps, and using the waste material. So that's also an important thing because your syngas can be produced by making use of a chemistry which is known as waste management. So you have a separate branch of course now after your 12th standard which can be done in waste management also. So because these days we are producing so much of waste otherwise by making use of so much of technology, non-technological materials. So where do you dispose them off with the increasing population? So waste management has become another important thing. So I'm telling you these days syngas is produced from, it's given from sewage, sawdust, scrap wood, newspapers, etc. And syngas that is produced from coal is known as coal gasification method. When it is prepared from coal gas, then it is known as coal gasification. So that's another thing. And you can also produce, say it is difficult to obtain CO or H2 separately from your gas. So what is done is a little bit of carbon dioxide may be added up. Say you have the gas as CO plus H2. So what can be done is the production of dihydrogen is increased by reacting carbon monoxide of thin gas with steam in the presence of iron chromate. So when you put iron chromate in it, then you can separate it out. How? Because if you still get CO plus H2, that will not suffice the condition, so you need to have some kind of an oxidation coming in. So you make it CO2 plus H2, and what you get is H2 is just generated as gas. So what we do is, in order to obtain your dihydrogen, or just to extract your CO, we heat it with excessive steam in the presence of iron chromate, because of which your CO will now get converted to carbon dioxide. If this CO gets converted to carbon dioxide, we can separate out our H2. As it is getting produced here as well. So it is difficult otherwise to produce. Right? So just go through the methods of preparation of hydrogen once. They're very important. And I told you, why is your syngas method important? Because methanol. It is a commercial method for preparation of methanol. But remember that methanol is not the drink that is used as an alcohol. You all know the meaning of alcohol as alcohol till date, but it has a lot of chemistry involved in it. Methanol, when it is actually taken by some, say if it is taken and if people drink methanol, then they may turn into, it may cause blindness also, and it may have many disastrous effect on human health. So it is not the methanol which is generally taken. Yes? It is difficult to separate dihydrogen from water gas because the mixture in itself has such kind of an interactions. There are different types of forces which are operative now. When we talk about forces, I have already talked about different types of forces. What are the forces? So that makes me revise one more topic for you. That's the beginning of your solid state also. For those of you who've started doing, when we talk about different forces, you have you talk about ionic solids. This is just a revision. So we take a break. Ionic solids, we have covalent solids, you have metallic solids, and then you have metallic, non-metallic. So what we have, ionic solids, covalent solids, we have metallic solids and molecular solids. Generally when we talk about molecular solids, let's come to this category. Ionic का मतलब सबको पता है अब. Directional, non-directional का मतलब भी पता है. Covalent is like the covalent bonds वाला solids. Metallic solids are the metals वाला solids. So ले दे के you can discuss only one in detail, that is your molecular solids. So when you talk about molecular solids, they involve different forces which are there. And now when we talk about forces, we talk about different types of van der Waals forces. We talk about different van der Waals forces, and I told you van der Waals forces are not just one type of forces. There are a combination of different types of forces. What are those forces? You have dipole, 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 induced dipole, and then you have London dispersion forces. You have induced dipole, and you have London forces. Somebody just mentioned hydrogen bonded forces. Let me tell you, hydrogen is a special case of van der Waals forces, because when you talk about hydrogen bonds, we have already talked about hydrogen so much in details. Hydrogen is what? What are hydrogen bonds? When your hydrogen interacts with some electronegative element. So hydrogen reacts with some electronegative elements, it forms hydrogen bond. So that will be some kind of a dipole. Dipole की बात कब करेंगे? Whenever there is some kind of a separation in the charges. What is a dipole according to your physics? Two small charges separated by a small distance. So when you talk about two small charges, if you have H plus and you have Cl minus, those small charges हो गए हमारा, it forms a dipole. So dipole and a dipole. So hydrogen bonded forces are generally taken separately because their energies are drastically different than these simpler ones. So that is why it is a special case of the dipole-dipole interactions which is considered separately because of other differences, like you talk about resemblances and differences. ठीक है, तो यहाँ पे a combination of all these forces are important for any two molecules to interact with one another. So when you talk about CO and H2, there it is some kind of an interaction of the energies of H2 and CO which makes it impossible for them to get separated. Not giving you the exact data, but it is those interactions which generally play a role, the molecular interactions which play a role. Alright, now let's come on to another type of a hydrogen which is known as a nascent hydrogen. Heard of it? Nascent hydrogen, nascent as the name suggests, is like a newly born hydrogen. So, and it's not that stable also, it's a newly born hydrogen. So when you talk about a newly born hydrogen, means that it is generally produced as you have Zn plus you keep a dilute H2SO4. So there are chances that you immediately get ZnSO4 plus you have 2H. There are chances of a dihydrogen also getting produced. There are chances of a nascent hydrogen also to be produced. It is a better, and what is the characteristic feature of nascent hydrogen? Let me tell you. We are talking about dihydrogen. हमने पूरा redox chapter, the beginning of it, how did we do it? Addition of oxygen मतलब oxidation. Addition of hydrogen means reduction. So hydrogen, dihydrogen is known as a reducing agent by and large. So let me tell you, a better reducing agent than dihydrogen is your nascent hydrogen. And I have just given you the method of preparation. So what this nascent hydrogen does is, it is added to KMnO4 and it decolorizes it. You have KMnO4 plus you have H2SO4 plus 10H, that gives you K2SO4 plus MnSO4 plus 8 water. KMnO4 is pinkish purplish in color, so that decolorization happens when you add nascent hydrogen. So just a reaction which is to be gone through. Remember, from your entrance point of view, from your CBSE point of view, you will just go through your material as it is in the sense, thoroughly keep your concepts right, keep your writing ability strong. But when you have to prepare for the entrance examination, you should just have the concept right and just go through everything. Concept समझ के, when you go through things, you understand them better, so that whenever a new question pops up suddenly in the entrance examinations, you can at least understand it and answer to the best of your ability. ठीक है, तो अभी से ये चीज़ clear रखना that you have to understand the basics of all maths, chemistry and physics absolutely proper, so that you can just go through things. Now if you go on to memorize each and every reaction, it will be a Herculean task for you for the entrance. And entrance examination means the whole world is open to you for questions. So you cannot go on to memorize equations for that, just go through. And then you will perform better in your MCQs. So just keep going through them. Okay, so now then we talk about the reactivity order of the hydrogens. Now we have talked about atomic, we have talked about the molecular hydrogen, that's H2. We've talked about nascent hydrogen. Nascent hydrogen is like your H, which is like, this shows that this is a little unstable, and then you have your atomic hydrogen. Out of all these, you have to arrange them according to their reactivity order. Which will be the most reactive, which has the shortest lifetime? Which is the shortest lifetime?
Nascent hydrogen.
Atomic hydrogen. Because the moment it becomes an atomic hydrogen, it will immediately form your, and remember, yes. See, it is nascent hydrogen. See, atomic hydrogen is the one which is created generally from some kind of a hydrogen compound in such a way that it is like absolutely in an atomic form. Nascent hydrogen is a short-lived species. During a chemical reaction it forms and it gets utilized in the chemical reaction itself. Whereas you have nascent is absolutely the newborn. You keep it stable for some time, it becomes an atom. Right? That kind of a thing. Yes, yes. Hydrogen remains hydrogen with just one electron. इसमें इससे ज़्यादा कुछ है ही नहीं chemistry में. So what you have is atomic hydrogen followed by nascent hydrogen followed by dihydrogen. And normally your nascent hydrogen, which is the Nascent hydrogen is generally formed during the chemical reactions in aqueous media. This is another property. Your atomic hydrogen can be obtained better in a gaseous phase, whereas in case of aqueous media, you generally get a freshly one, which is like an absolutely new. So nascent hydrogen is generally produced in aqueous media. Then the properties of dihydrogen are given as, let me talk about the properties. It is colorless, odorless, tasteless, right? And then it's insoluble. You're saying yes as if you've tasted it. So you have colorless, it is colorless, odorless, tasteless. Then it is insoluble in water. H2 of course is insoluble in water, and then you have it is highly combustible. It is highly combustible. These are the general properties, and we've talked about, yes, the data for which I told you I don't remember is now given here. When you talk about the question, say H2 at 5000 Kelvin is, I told you what does it give? H plus NH, and here delta H, you can note down the data if you left it blank before. It is 435.9 kilojoules per mole. I told you around 500 kilojoules per mole, it's 435.9. And remember that H2 has a very high bond dissociation energy. क्योंकि इसको हम कहेंगे, this will be called, ये bond है, ये bond टूट गया. So what will this be called? The bond dissociation energy. So this is also the bond dissociation energy, which is very high. And if your bond dissociation energy for any molecule is very high, it is said that the molecule is inert. ठीक है? It is very inert, stable. जो react नहीं करेगा वो stable ही रहेगा, unless that thing goes into depression. So got it? So it is H2 gives you H and H, and the bond dissociation energy is very high. So now if I ask you a question related, now the importance of this chapter, all this and something more you must have done already. If I give you a question like, why is dinitrogen inert? So what will be the answer? Because the bond dissociation energy is very high. So without giving the values, you can just give a reason. So I'm just relating one of the questions to it. Okay. So hydrogen reacts with many elements because of its hydrogen configuration. This is what we've discussed. It can lose an electron, it can gain an electron, and then it can actually share an electron also to form a covalent bond. Giving and taking up we've talked about. Giving makes it similar to the alkali metals, taking makes it similar to halogens, and it can share also to form covalent bonds, right? Now reaction with halogens. Let's talk about some of the reactions. Reactions first of all with halogens, which is like H2 plus X2, that gives 2HX. And generally it is where X is your halogen. Okay. Now generally all these reactions happen at some temperature or in the presence of light. The reaction with fluorine is the only reaction that can occur in the dark also. Uske liye light is not required. Reaction with fluorine can occur in dark also, because that depends upon the energy. Fluorine is like, as it is like, has a small atom, so there is like the size compatibility also in this case. So H and F as it is, they can just quickly react with one another, and better answer can also be given in the form that see, in this case when you actually have H2 in itself gets oxidized quickly to H plus. Fluorine is highly electronegative, so it will immediately try to become F minus. So its electronegativity and its electropositivity gets combined together, and they highly want to interact with one another, so that can happen in the dark also. So what you have is, you can also have, and as you move on to bigger and bigger size, say from fluorine occurs in the dark, chlorine happens in sunlight, then with bromine, say at a temperature of around 650 Kelvin. With iodine you need a catalyst also. So as the size increases, the reactivity conditions need to be increased according to that. समझ में आ रहा है कि H2 जब F2 के साथ react करेगा, we did talk about both their natures. Yes, you can relate it to oxidizing power of halogens. It is going on decreasing down the group. Very fine. So it's all related to one another. So I'm giving you the factual experimental conditions. पहले वाले case में the reaction occurs in the dark. Second case में it Cl2 के साथ sunlight में. Bromine के साथ it needs a temperature of around 600 to 700, 673 or something Kelvin. And then with what is left? Iodine. Iodine is a big molecule, so catalyst also. ठीक है? Then we are talking about, now you write down the reactions yourself. If I talk about the reaction with O2, this is going to be tricky. What is formed? Water. सोच रहे हो क्योंकि tricky है. Otherwise you can have in other conditions formation of other oxides of hydrogen also. You can have H2O2 also. But here if you given the condition of simple heating, you get water getting formed. Then with the nitrogen, then if you have, very good. So with nitrogen it forms ammonia. What is the significance of this method? This method is known as Haber's process. And what are the temperature and conditions, atmospheric conditions? 673 Kelvin, 200 atmosphere. Then it requires a catalyst also to form 2NH3. So this is Haber's process, which will be used time and again in your chemistry now. Then the reaction with metals. Let me just give you two metals and you write down the reaction. I'm sure you will be doing it. 2Na plus H2 will give you what? Ca plus H2 will give you what? I want the formula. Hydride बनेगा ये तो सबको पता है. In the first case it will be Na plus and H minus. So क्या बनेगा? N2NaH. So here you will have 2NaH. For the next case what will be formed? Ca is 2 plus, H is minus. So it will form CaH2. The basic chemistry. Now you are like capable of teaching youngsters. I mean younger students. You all are also youngsters. You can teach, but you have no time. You have to study for yourself. So make sure that you keep doing that. All right. Then dihydrogen is also. We've already talked about its reducing properties. It acts as a reducing agent. So if I make H2 react with PD2 plus, so what will it do? You remember the reactivity series that I gave you? PSBC, magenta, hydrogen, copper, silver, gold, platinum. And then palladium also falls in that category. So palladium is lesser reactive than hydrogen. So hydrogen can easily replace it in its aqueous medium. ठीक है, याद रखना. अब दोनों में से aqueous medium में कौन है? PD2 plus. क्योंकि आयन जो होगा वो aqueous medium में होगा. So hydrogen can replace it in its aqueous medium to form 2H plus plus PD. Got it? So if you have any kind of a metallic solution which is there, you add dihydrogen to it, so you can extract the metal out of it. जैसे palladium, platinum, catalyst तो हमें चाहिए ही होते हैं. तो palladium का कोई solution है, we add dihydrogen to it. तो palladium solution में will be in the ionic form. So dihydrogen will replace it from its ionic form and will itself get oxidized and reduce your PD. Remember that had I written this reaction as PD plus H plus, what will it be? No reaction. Why no reaction? Because PD is lesser reactive than, this is from your earlier things that you've already done. Okay. Then there is another reaction that is generally put here. You can have say any number of moles of H2 reacting with Mx and Oy to form what? Where your Mx, according to me, your M should be lesser reactive. So what will you have? You will get the corresponding metal plus what is H2O going to form? Water. So you will have X of M getting separated now because it's in the 2 plus form or whatever, sorry, in My plus form. So you get X M of Y plus. No, the Y plus now gets changed because your H2 is getting formed. So you have plus Y Just a general reaction that you can otherwise cater to easily. Then another important reaction will be, this is something that you must have done in organics, so I don't need to repeat it. How do you convert the unsaturated hydrocarbons to saturated hydrocarbons? पहले unsaturated वाले कौन से होते हैं? The ones which have a double or a triple bond. The single bonds the ones which have only single bonds are saturated. So if I give you a reaction of CH2 double bond CH2, this is your ethane, plus H2 at some temperature of about 473 Kelvin, and so you heating it in the presence of a catalyst, nickel, palladium, platinum, anything. So what do you get? So ethene gets converted to ethane. So this is generally known as catalytic hydrogenation, क्योंकि catalyst के presence में you are bringing about hydrogenation. So this is known as catalytic hydrogenation. So you have CH2 double bond CH2 plus H2 giving you ethane, and that is catalytic hydrogenation. So then similarly you can bring about hydrogenation of vegetable oils also. This is one hydrogenation reaction, catalytic hydrogenation. Then you can bring about hydrogenation of vegetable oils also. Vegetable oil plus H2, when you bring it about in almost the same conditions, what will happen? All the double bonds will get saturated, all the double bonds or the triple bonds, whatever is there in your vegetable oil, and what you get is dalda, vanaspati ghee and all. Yeah. Simply by passing hydrogen through it. Then you have another important reaction that you will be doing for the preparation of aldehydes is like, from here only I'll pick it up. Say supposedly I take an alkene, ठीक है? Alkene में मैं H2 डालूंगी तो हमें पता है we'll get simply alkane, ठीक है? But if I just make about a little more changes to it and bring about CO, so this is a very important reaction. What is this? Water gas. हम dihydrogen produce करते time we can even produce a water gas. This we've seen in the preparation. Once we get a water gas, make it react with your alkene. भाई यहाँ पे H2 available है तो alkane बना लो. अगर water gas available है तो कुछ और बना लो. So in this case you have water gas H2 plus CO. You make it react with alkene, and what will it do? It will form an aldehyde. What is your aldehyde? CHO. And that too, why is it a special reaction? It will give an extra carbon now to your alkene. See, in order to make this reaction you must have done before. I'm just reminding you. This is CH2. Ozonolysis reaction किया है ना last year? अभी? So what you have RCH double bond, you add ozone to it. So what will it form? RCHO 2 O and O, and then you bring about the hydrolysis of it in the presence of zinc or some other metal atom. So what you get is RCHO plus HCHO. This is formaldehyde. This is depending upon which aldehyde you want. ये reaction तो सबको पता है ना? So what is happening in this reaction? The number of carbon atoms are getting reduced. So for each reaction you have to take care. Each reaction has its own importance. In ozonolysis the number of carbon atoms is getting reduced. Now if I ask you to prepare, ये तो aldehyde हो गया from alkene. Why am I relating it to alkene? Because I'm talking about alkene only. Aldehyde, if I have to prepare from alkene, with lesser number of carbon atoms I can use ozonolysis. If I wanted with greater number of carbon atoms, I can use the reaction with water gas, right? So in this case the product that will be formed, and you can also bring about oxidation. You can also form RCH double bond CH2. यहाँ से when you bring about the oxidation, I'm not making you do that reaction right now. You can also form RCH2 CHO. If I make this reaction react with some oxidizing agent like CrO3, तो मुझे उतने ही carbon atoms वाला aldehyde मिल जाएगा. So मैंने आपको, I am telling you the reactions of alkenes now to form aldehydes, because we are talking about the preparation of aldehydes. When you do ozonolysis, you've recently done it. When you do ozonolysis, you get aldehyde with lesser number of carbon atoms. When you do it with a mild oxidizing agent, you form an aldehyde with same number of carbon atoms. And now when you want to increase it, you make use of this, and what it forms is, let me just finish it off by writing CH2 CHO. So this is with an increased one number of carbon atom. This is also called as hydroformylation of olefins or alkenes. One same thing. Hydroformylation of olefins. फिर अच्छा हाइड्रोजन का ही रिएक्शन यहाँ लिख रहे हैं ना, तो यू वुड बी यूजिंग डाईहाइड्रोजन अगेन एंड अगेन इन योर ऑर्गेनिक केमिस्ट्री फॉर डिफरेंट कन्वर्जन्स. जैसे यहाँ पे हमने क्या करा, इट इज सम काइंड ऑफ एन ऑक्सीडेशन. व्हाई इज दिस एन ऑक्सीडेशन? बिकॉज वी आर एडिंग ऑक्सीजन टू आवर मेन मॉलिक्यूल. ये आर एल्कीन था, एल्कीन से हमने इसको बना दिया एल्डिहाइड, तो उसके पास ऑक्सीजन तो आ ही गया ना. सो देन इट इज कॉल्ड एन ऑक्सीडेशन. Otherwise if I simply react it with H2, so what will happen? I will get an alcohol. बात समझ में आई? Now if I want to prepare from aldehyde, I add H2 to it, it will form alcohol. क्योंकि एक H जाएगा इस कार्बन के पास, एक H जाएगा इसके पास, ऑक्सीजन के पास. So what will I get? I'll get RCH2 CH2OH. So if I want look at the organic chemistry part of it. If I want an alcohol from an alkene with increased number of carbon atoms, so understand, पहले aldehyde बनाओ, aldehyde में dihydrogen डालो and you get alcohol. See, once you get aldehyde, then to get alcohol is like a cakewalk. So you should just know different ways of getting the aldehyde. So generally this is how you are given the problems in organic, and you say it's very tough, lengthy. It's nothing lengthy, you just have to understand. You have your final product given, you have your initial product given. You just have to look at it completely, and then the more you practice, yes, the more you become a master of it. You have RCH double bond CH2, and if you have to form an alcohol. Now what is the difference? With increased carbon atom. Then you think how to increase the number of carbon atoms. Then you think of this reaction and come to this reaction. Right? Otherwise, there are ways of preparing alcohol directly from it also. What you can do? Simply add water to it. If you add water, तो ये क्या होगा? Hydrolysis. We are breaking a water molecule as HOH. ठीक है? तो you remember the Markovnikov's rule? Hydrogen goes to that carbon atom which has greater number of hydrogen atoms. So here hydrogen goes to this carbon atom, you can get an OH here, and you can make it follow the anti-Markovnikov's rule also. वो HBr के साथ पहले react करो, फिर Br को replace करा. So you know it all. So just have to put your minds to the same. Now but we are talking about dihydrogen only. So let's come back to hydrogen. ठीक है? We make this now react with dihydrogen and we get an alcohol. So we can have more reactions of the same type. That is like one reaction. Let's talk about another reaction. Uses of now dihydrogen are like related to it. Look at the chemical reaction once. I give you exactly 10 seconds for doing that. Look at the reactions that you've jotted down. The reactions of dihydrogens. Each one of them is very simple. You knew the reactions. Now tell me, by and large, major uses कौन से निकालोगे? One is for the very good. One is for the preparation of ammonia using the Haber's process. That's a commercial method. Another is for the preparation of methanol. But methanol is prepared from water gas. And how is your water gas prepared? So that also becomes an important reaction. So yes, carbon plus H2, coke plus steam. So that all gives you your water gas. So this is again an important reaction. Any other thing, it is used as a very good reducing agent. So wherever it is reducing in metallurgical, so use क्या आया? अगर reducing agent है, it can extract your metal. That means it can be used successfully in metallurgical processes. So you know the uses on your own. Once you go through the reactions carefully, you can think about uses. क्योंकि real life में use तो यही है. Otherwise, chemistry first you understand and then you think about how you can apply it to real life. Okay, it can be used for cutting and welding purposes. How do I explain that? There is an atomic hydrogen torch which is available with the welders, oxyhydrogen torch or whichever torch you have. So in that, your not water, dihydrogen is split temporarily into the atomic hydrogens at a temperature of 5000 Kelvin, and then suddenly it becomes back to H2. So it melts your, at that particular temperature, it melts it, and then suddenly there is like bond which is formed between your whatever you want to weld up. So that is done. Do not try it on your own. Then you have, it's used for rocket fuel, because in rocket fuel you have liquid hydrogen and liquid oxygen also. So dihydrogen has its own importance. Liquid hydrogen is an important fuel used in rockets. Then another one is, it's used for fuels. Yes, you can prepare ghee also from dihydrogen. So you know a number of uses can be actually thought of once you go through the reactions intricately, right? Then we can now talk about the hydrides quickly, types of hydrides that we can have for hydrogen. Types of hydrides that we can have for hydrogens. You know what are hydrides, right? It is like wherever you have hydrogen in H minus form in your molecule, that is hydride. In hydrides, you can have three types of hydrides. You can have ionic hydrides, then you can have, see, ionic ones are the saline or the, they are known as the salinic hydrides or salt-like. Saline means salt-like hydrides. Covalent hydrides are the ones which are generally the molecular hydrides. And then you can have metallic hydrides, or somebody said interstitial, or you can say non-stoichiometric hydrides. So you can have different types of hydrides. What are those? You can have ionic hydrides, covalent hydrides, and you can have metallic or non-stoichiometric. So I'll just take up the examples and you will understand it all. Generally, ionic hydrides are the ones which are white crystalline powdered structures. And now you know the meaning. If I am saying crystalline, you understand the meaning of crystalline. Because when you talk about solids now, you must have started with solids. There are two types of solids. One are the amorphous, very well, and the other is crystal. So all of you are sincere and serious at the beginning of your 12th. Hope you maintain that throughout. So you have crystalline and amorphous structures. Amorphous has a long range order, crystalline has a short range order, and because of that short range order, they have a sharp melting point. Whereas when you talk about the amorphous solids, they have a range. So if I am talking about ionic hydrides to be crystalline powder, I mean to say they have a sharp melting point. Okay, so here you can also think about, they are generally non-volatile in nature and non-conducting also. You have like NaH, that's an ionic hydride, where you have Na plus and H minus. Can you write down the reaction at cathode and anode for both of them? If I ask you to write down the reaction of NaH for the at cathode and anode, can you write down? At cathode, what will be coming up? Your Na plus will interact, will accept an electron. और अभी मैंने बताया है what is going to happen at anode? Oxidation. Oxidation मतलब loss of electrons. That means you will have Cl minus plus electron now. So you will have, sorry. Now you have H. In anode, anode you know will be where you will have your anions coming up. So you have the loss of electrons here. So H minus will be giving you H plus electron. Right? So you talk about at anode oxidation, which is nothing but the loss of electrons. This sums up one of your chapters of 11th grade. Right? They burn spontaneously. Ionic hydrides generally burn spontaneously in air. Burn spontaneously in air. Remember when I talk about burning, combustion, anything, it's a reaction with oxygen. So you talk about another ionic hydride, say CaH2, and write down the reaction of burning. That will be You can have H2 gas also getting produced here, H2 also can get produced here depending upon your reaction conditions. So remember that they burn spontaneously in air to give you calcium in this case and hydrogen, dihydrogen. So from your CH2, it will immediately get dissociated to give you calcium and dihydrogen. Then you can have, they can also form useful hydrides, like you have lithium hydride. Okay? Lithium hydride, when it reacts with, this is again an important reaction, Al2Cl6, it forms your very important reducing agent, which is your LiAlH4. Lithium aluminium hydride, which is a very, very, very important reducing agent that you will be using time and again in your reduction reactions. So you have LiH plus Al2O6, that's normal lithium hydride to give you lithium aluminium hydride. And why do we prepare that? We prepare that because it has better reducing properties. Otherwise there is no point. 6 LiCl. And similarly, if I write down, these reactions have been picked up from your previous year question papers only. So LiH plus B2H6 will give you, similarly, you will get LiBH4 plus, check out the side product. Then for covalent hydride, done with ionic? Ionic, we've just discussed some properties. See, you can write down the reactions as it is in electrolysis reactions. You can write down the reactions at cathode and anode. Ionic hydrides, you know, ionic are like by the transfer of electrons completely. And then you have seen that they will be good reducing agents, and how to make better reducing agents from them is by making them react with diborane or the dimer of AlCl3, that is Al2Cl6, and you will immediately get your LiAlH4 or LiBH4, right? So you can get better. And then another property that we discussed for ionic hydrides was that they burn spontaneously in air. The next one that we can discuss is covalent or molecular hydrides. Give me examples. Covalent. All these covalent structures you have actually taken up one by one. Remember that covalent are, I tell you, covalent structures are generally directional in nature. Why are they directional? By the virtue of what concept? Why are they directional? Because you know CH4 will have its CH and CH bond at a particular angle. What is that angle? 109 degrees 28 minutes, right? How do you get to know about that angle? By the hybridization. What is the hybridization in this case? sp3. So generally all your covalent structures are associated with some or the other type of hybridization, and by the virtue of hybridization it is that these bonds are directional in nature. This is a very common question, that what are directional bonds, what are non-directional bonds? Non-directional bonds are your ionic. This, let me just remind you, I have told you before but I'll just remind you, ionic bonds are called non-directional in nature because irrespective of the direction from which your anion is approaching the central cation, it will experience the same force. Jaise NaCl is your ionic solid, so if you have Na plus in between, Cl minus kisi bhi direction se aaye, it will form NaCl only with the same electrostatic force. Cl will experience the same force from Na. So this will be nothing but, this will be a kind of an ionic or a non-directional structure. So
In the example of NaCl, we have considered it to be non-directional because in the lattice it is equally spaced.
no. See, if I want to form NaCl, first of all, I will choose some compound of Na and some anionic species which is giving, some species which is giving me Cl minus. So when my Cl minus has to approach to Na, that is, what is the energy released when Na plus and Cl minus will come close to one another? Lattice energy. Remember, when two ions from infinite distance apart, they come close together to one another to form a bond, the energy released is known as lattice energy. We've done, again, I can spend one full day on it. So you have Na plus and Cl minus interacting. Now Cl minus, from whichever direction it may come, it will experience the same force from Na, because it just has to interact by transfer of electrons. But here in this case there is particular sharing of electrons, and the other atom, अगर CH एक bond बन भी गया, the other CH bond has to be in a particular angle. That is by the virtue of hybridization, which sets your angle for a particular structure, and so that there are minimum repulsions to complete the chemistry part of it. So there are minimum repulsions. So you have CH4, and then in this you can have electron deficient hydrides also. Electron deficient hydrides are like B2H6, that is an electron deficient hydrides. And then you can have electron rich hydrides also. Electron rich hydrides is like, one of your electron rich hydrides is like H2O. Why? Because it has two lone pairs. What about your ammonia? It has one lone pair. Okay. So in metallic hydrides, let me just talk about the last one. You have metallic or non-stoichiometric hydrides also. When I talk about non-stoichiometric hydrides, they are of the type of LaH 2.87. You have Ya. These are like all your transition elements. Generally, the non-stoichiometric hydrides are also known as interstitial hydrides. Okay, I will just explain the meaning of it. You can have Ya, I am just picking up exactly from it so that I don't give you the wrong ratio. Here you see that if I am talking about the non-stoichiometric or metallic hydrides, when they interact with a metal, the stoichiometry is not integral. Because abhi tak what we were doing was like BaH2 or CaH2, you talk about CaH2, so the ratio is 1:2. Now here the ratio is, why is that the case? आप सबने solid state start किया है? Have you started with solid state? No. So see what happens is like, this is my solid state structure. Okay, normally one atom is like this. Assume it to be a cube. एक crystal ordered structure ले रही हूँ, तो this the another will be another cube. ठीक है? Say इसी, तो क्या है? All these atoms are here. Now if I have A plus here, B minus here, then B minus here and A plus here. This is some kind of an ionic solid or some kind of a hydride or whatever molecule I am talking about. If I assume that some bit of it comes here in the interstitial space, I am explaining it in a weird fashion, but to explain it to you. If one of the atoms occupies this interstitial space, it may be assumed that it will not be a complete atom fitted in there. So we assume it to be in some kind of an the ratio gets disrupted if any of this thing happens. ठीक है, इसका एक example मैं लेके समझाती हूँ that you will be doing now in your 12th grade of FeO. FeO में Fe का oxidation state क्या है? क्या है? +2. This is -2. Now say supposedly if for some reason some of the ions are missing from their lattice positions. If some of the ions are missing from the lattice positions, we heat the crystal or do something, some pressure changes or something, कि जो ये हमारा lattice है इसमें ना सब atoms की एक जगह बनी होती है. There are seats for everyone. So your Fe sitting here, O is sitting here, Fe sitting here, O is sitting there. It's like an ordered pattern. Just to give you a very basic picture. Fe is 2 plus. Some of the Fe, if it is not there, तो उसको compensate करने के लिए what it does is, some of the Fe2 plus becomes Fe3 plus plus an electron. कुछ समझ में आ रहा है? So in order to compensate for the loss of Fe from FeO, some of the Fe2 plus become Fe3 plus plus electron. तो उसकी वजह से क्या होता है कि now you have a mixture of Fe2 plus and Fe3 plus. So as a result of which the stoichiometry that was 1:1 earlier gets disturbed, and your Fe becomes FeXO, where your X turns out to be less than 1. So then that disturbs the stoichiometry. इसमें we believe that some of the hydrogens or some of the metal atoms may be occupying the interstitial void, and that is why these non-stoichiometric hydrides are also known as interstitial hydrides. Interstitial space होता है कि जो मेरे atoms की space बनी हुई है उसके बीच में अगर कुछ space बच रही है, so this is my interstitial space. So if that is being occupied, it will disturb the stoichiometry, and if stoichiometry is disturbed, you call it non-stoichiometric compound or interstitial hydrides, as in case of hydrides, right? So from here we'll continue tomorrow. All the best. Thank you.